Alright, okay, hello, my name is Ashraf, so I'm going to teach you guys on the chemistry for SPM. Alright, okay, so just now I covered on the sodium hydroxide solution for the cation test. I'm going to proceed with the ammonia solution, okay? Alright, same things for the ammonia solution, okay? You can see there will be a few drops first, okay? Few drops, the same method just now. You just add a few, 3 to 4 drops into your test tube that contain the unknown salt solution, and then you can see a white precipitate occur. Okay, so when you see a white precipitate occur, we can narrow down a little bit our cation into magnesium, potassium, aluminium, and also zinc. Okay, as you can see here lah. This part, okay, so it could be that 1, 2, 3, 4 of the cation. Okay, so what about others? All right, so let's say you drop a few drops of ammonia solution, there's nothing happen. Okay, there is no precipitate, there's nothing happen at all. So meaning that your solution could contain calcium ion or ammonium ions. Okay, all right. Okay, next one. When you see, let's say you see there is a white precipitate happen, okay, we're gonna add our ammonia solution in excess. In excess meaning you top up until 2/3 of the test tube, and you can see two possibilities also, which is there will be a remaining of that white precipitate, or your white precipitate is gone or dissolved. Okay, so let's say you have white precipitate, okay, when you add in excess, meaning there is a possibilities of magnesium, aluminium, and also potassium contained in the that unknown salt. Okay, so let's say when you add in excess, the white precipitate just now is gone, meaning it's dissolved. There will be only one possibilities, which is it might be contain a zinc ion. Okay, all right. Now look at this table on the next side of this slide. Okay, copper 2 ions, blue precipitate, iron 2 ions, green precipitate, and iron 3 ions having a brown precipitate. Okay, what does it mean? Okay, just now I told you guys, right, when you add a few drops, you can see for these 5 ions, you will see the white precipitate. Okay, what if you observe a colored precipitate? Okay, what I said by colored precipitate is these 3 things lah. Okay, blue precipitate, green precipitate, and brown precipitate. If you see a brown solid precipitate occur when you add a few drops of these 2 solution, meaning that it might be contain copper 2 ions. Okay, if you add a few drops of these 2 solution and suddenly you see a green precipitate, that salt might contain a iron 2 ions. Okay, and lastly, if you see there is a brown precipitate meaning a rusting colored lah. Okay, might be that your unknown salt contains iron 3 ions. Okay, all right. So now we go for the cation test for confirmatory between lead and also aluminium. Okay, if you can see here, okay, I'm gonna clear this highlighted part here. Okay, if you can see, okay, the observation that you can see for these 2 things here, lead and also aluminium, okay, they are close to one another. Okay, they are close to one another, which is your PA and PA at this side here, and here, they are in the same observation. Okay, what I mean by same observation is that when you use sodium hydroxide, example, I give you an example. The first one, you use an AOH. Okay, you use an AOH, you see in excess, there will be a clear solution. Clear solution meaning dissolve. Okay, it is dissolved. Okay. Secondly, you use ammonia solution. Okay. In excess also, you will see that this one. Okay, so you use NH3 in excess. There is a white precipitate remain. Okay. Okay. Alright. So now based on these two observations, the first one, you use sodium hydroxide in excess, clear solution dissolve. Okay. Clear solution dissolve, meaning it could be, okay, it could be from this one. Okay. It could be lead, aluminium, or zinc. Could be. Okay. Second test, you use ammonia. Okay, you use ammonia in excess. There will be a white precipitate remain. Okay, you still can see the white precipitate. All right. So this tell you that it might contain magnesium, aluminium, and also lead. Okay. So now I'm gonna highlight these two things here. Okay. Here and here. Okay, they fall in the same categories. Aluminium and lead fall in the same categories, which is, if you got this kind of observation, you don't know what is the salt. Correct or not? You cannot narrow down. There is two possibilities. So this is when you need to do a confirmatory test. Okay, confirmatory test, because we want to confirm whether in that salt contain lead or aluminium. Okay, so this confirmatory test, basically you react the solution with potassium iodide. Okay, you are reacting the unknown solution with the potassium iodide. Okay, so there is two observation that you can get from this test, which is, it's either you get the yellow precipitate or you get clear solution, which is nothing happened. Okay, alright. So if you get a yellow precipitate, it indicating that your unknown salt contains a lead ion. Okay, contain lead ion. If you do this reaction and you see there is a clear solution, meaning you have a soluble salt, it might tell you that the unknown salt just now is contain aluminium ions. Okay, alright. So as you can see here, what about aluminium ion? Aluminium ion, no observable reaction. Okay, no observable reaction, nothing changes. Okay, if you use let's say this one contain Pb, right? Okay, Pb2 plus, you react with the potassium iodide, you will see a yellow precipitate. Yellow precipitate indicating that the Pb is there. Okay, because Pb is reacting with the iodide ion to produce insoluble salt. Okay, that's why it can form a precipitate, a solid, because it is insoluble. Alright. Okay. Now we move on to the next test, which is our anion test. Okay, alright. 4 types of anion that we covered in the syllabus is carbonate, chloride, sulfate, and also nitrate. Okay, so how to memorize this one? Okay, actually there is one thing that we can add here. Okay, I simply put NO there. Okay, why? Okay, because this is how I memorize this. Okay, now you see here, NO, Cl, SO, NO, just like that first. Okay, so how I memorize this is no clue, so nothing. Okay, no clue, so nothing. Why I arrange the anion like that? Because later on I will explain why. Okay, alright. Let's say you want to test the presence of chloride ion. Okay, alright. So first of all, for the test of anion, you need to add acid. Okay, you need to put an acid into your unknown solution. Alright, so let's say you have your sample here. Okay, your sample here might contain Cl. Might contain Cl. You don't know yet. Okay, because you need to do tests only, then you know. Right. So first of all, you're gonna add a acid. But what kind of acid that you need to add? Okay. Now we need to look on our previous anion, which is NO. Correct now? Okay. We need to look on our previous, which is NO. NO meaning that the acid that you need to add must contain a nitrate ion. Okay, what acid that contain a nitrate ion? Okay, so this is the answer. Okay, a nitric acid. Okay, first step first, you need to add nitric acid. Okay, and after that, you need to add silver nitrate solution. Okay, the first step, this one, second step, this one, and you can see a white precipitate. Okay, so what does that white precipitate indicating? Okay, so this white precipitate are telling you that on your salt just now contain a chloride ion. Why I said so? Because here, this one having silver cation, correct? Got Ag plus there. Alright, so when this Ag plus react with the react with the chloride ion, it will form silver chloride. Okay, this one, if you recall back on our previous lesson, silver chloride is a insoluble salt. Okay, so that's how we know that inside here, inside your unknown salt just now contain a chloride ion. Let's say this one contain nitrate, example. So your nitrate will react with the silver, so it will produce a silver nitrate. Silver nitrate is a soluble salt, which is there is no observable reaction that you can see from the reaction. Correct or not? Okay, so that's why we must add a silver nitrate in the chloride, because we want to see whether there is a reaction or not. If there is a reaction, meaning inside there might contain a chloride ion. Okay, alright, now move on to the next anion, which is our sulfate ion. Okay, so the first thing first, same method. Okay, we gonna add acid. Okay, but what kind of acid that we need to add? Right, now look at the previous anion. Okay, previous anion is chloride. Okay, so what kind of acid that contain a chloride? So here is your HCl. Okay, hydrochloric acid. Okay, first step is add HCl, and the second step add barium chloride. Okay, why I need to add barium chloride? Because I want to see a changes. Okay, I want to mix the anion, which is the sulfate just now, with some cation which can produce a insoluble salt. Okay, so sulfate salt, what kind of cation that you can match with the sulfate to produce a insoluble salt? Okay, so that's why I choose a barium chloride. Okay, so barium chloride is this one is a soluble salt. Okay, soluble salt. Okay, because I want to use solution. If I want to use solution, I need to use a soluble salt. Okay, alright. So when barium chloride, inside a barium chloride, there will be a Ba2+. Okay, there will be a Ba2+ ion. So when this barium ion react with a sulfate ion, it will produce a barium sulfate. Okay, recall back on the solubility of salt. Barium sulfate is insoluble salt. So when you have a production of insoluble salt, you can see a solid occur or precipitate occur. Okay, so that's why you can see here a white precipitate will happen. Okay, a white precipitate will happen here. Alright, okay. Now for the next anion, okay, which is a nitrate ion. Okay, same things. First step, you need to look on the previous anion, which is our sulfate. Okay, first step, add acid. But what kind of acid? acid that contain a sulfate ion. So, which acid? Sulfuric acid. Okay, H2SO4. Okay, but you need to look at here. H2SO4 diluted. Okay, need to add a diluted H2SO4. And then, you need to add a iron 2 sulfate. Okay. But this one contain 3 steps. Okay. One step acid, second is iron 2 sulfate, and then the next one you need to add H2SO4 concentrated. But there is a method how to add the concentrated acid. Okay. Once you do the addition of iron 2 sulfate, you need to tilt your test tube like this. Tilt meaning you need to put side like this. Okay, because later on you're gonna drop using a dropper to the wall of your test tube that contain your sample here. This is your concentrated H2SO4. Okay, when you add a concentrated H2SO4 to the wall of your test tube, you can see the formation of a brown ring. Okay, the formation of a brown ring will present, indicate that inside your unknown salt contains a nitrate ion. Okay, so basically only nitrate have one extra step. Okay, the formation of the brown ring, and then you need to tilt a bit your test tube. Okay, so now look, we covered for the chloride, sulfate, and also nitrate. Now look on our last anion, which is our carbonate. Carbonate, very simple, very easy. Okay, the step that you need to do is you just need to add an acid into the sample, and you can see in the sample there will be a effervescence happen. Effervescence is like a frizzy small bubble will produce, and then if you flow the gaseous form into a lime water, it will form and your lime water will turn into a cloudy. Okay, your lime water will turn into cloudy, or some book said chalky, or some book said milky. Okay, indicating the presence of a carbonate. Indicating the presence of a carbon dioxide, which coming from a carbonate ion. Okay, alright. So I'm gonna continue my lesson with a sample of question that we're gonna use all of this knowledge later on. Alright. Okay. Thank you. See you on the next session.